In this video, I'm going to walk you through the paired sample t-test where you want to estimate a precise p-value. Now again, you could do this in a dedicated software program for statistics like SPSS or SAS or R and do it very efficiently. I'm just showing you this extra way of doing it so that you have a bit more of an understanding of statistics and another way of doing it, and the example is through Excel. And I'm assuming that you've already covered the video relevant to the standard error, the difference between two related means, as well as estimating the 95% confidence interval associated with mean difference scores from paired observations. So I'm assuming you've done that. And if you know how to do those things, or you have some familiarity with it, really all you need to know is that there's a calculated paired sample t-test formula, which is the mean difference scores divided by the standard error of the difference scores. And then once you know that paired t-value, which is a calculated t-value, you can use this Tdistribution function to evaluate how improbable that t-value is relevant to a t-distribution with specified degrees of freedom and the number of tails, which you should probably always use 2 tails. So let's go back to the Excel sheet where I calculated the 95% upper and lower bound for the mean difference equal to 0.659 between mean 1 and mean 2, which is GPA pre and GPA post. So all I need to do is calculate the paired sample t-value calculated from this formula here, which seems big, but really we've done most of the work already. So calculated t equals the mean difference, which is equal F5 divided by the standard error, which is standard error of the difference, which is F8. So standard error of the difference and mean difference. So mean difference divided by standard error difference, which gives me a negative 4.16763. Now I need to make reference to the t-distribution to see how improbable this t-value is, or an even larger t-value with a specified degrees of freedom. So what are the chances I would get something like this or something even bigger just by chance? Well, probably not very likely, and we can use the Tdistribution function to call that up in Excel to see what the value is. So this is going to be a p-value, and I'm going to write equals Tdistribution, and it's telling me, well, what x value do you want? What is the calculated t-value? So that's F15. I think it has to be positive, so I'm actually going to have to change that to a positive value. So I'm going to have to make that into an absolute value. So let me just write 4.16763 and equals Tdistribution, and x equals G15. Degrees of freedom are equal to 44, so F9, and 2 tails. And I get a value of 0.000142, which is less than 0.05. Therefore, I can reject the null hypothesis of equal means. So it looks like setting goals, learning how to set goals, can help improve your GPA based on this study where I simulated data to correspond closely to that study. So there are 2 ways to think about it: that the difference between the 2 means is statistically significant, or that the mean of the difference scores is statistically significant. It's saying exactly the same thing. So this is how most people would conduct a paired sample t-test, is they would get the calculated t-value and they would get the p-value. Now, as I mentioned in the textbook, the fact that the 95% confidence intervals associated with the mean difference were both on the same side of 0 necessarily implied that the p-value was going to be less than 0.05.